Nobody got quiet when I did that. That did not work at all. All right. Okay, now shut up. So, chapter 15, we're going to kind of extend on the rules that we learned in chapter 14. Chapter 14 were the very much basics. Okay, we learned addition rule and multiplication rule. And we're going to extend and add on to those two rules today. Darn it! I didn't put the thing up. We're going to extend and add on to those two rules for cases when, so addition rule, we had to have disjoint events, meaning events that cannot both happen at the same time. We're going to add on to the addition rule to make up for times when we don't have disjoint events. And we did the multiplication rule for when we have independent events. And we're going to add on to that rule for when we don't have independent events. Sorry, my little annotator wasn't on, so I had to go back and get that so that I got my happy little bar right there. So, okay, so here we go. So, when we had disjoint events from chapter 14, when there was disjoint events, we simply added the two probabilities. Probability of A or B was probability of A plus the probability of B. Okay? That works when the events are disjoint. However, when our events are not disjoint, that rule ends up double counting something. So, for example, just to give you a quick picture, if you had a Venn diagram that was like this, where this one here was P of A, and this one here was P of B. I know you can't read those because they're far away, but that's okay. If you were to simply add up everything in P of A and everything with P of B, this area in here is going to get double counted. Because when you add up P of A, you're adding up this whole circle, and when you add up P of B, you're adding up this whole circle, which means this little area in between got counted twice. Brittany? So this would just be, so for all probabilities, we can make up a Venn diagram to represent it visually. When we have disjoint events, it was like this. And when we add up the two circles, there's no problem. These, that's why we can't use this version of the addition rule when we have events that are not disjoint. If both P of A and P of B can happen at the same time, then this original addition rule doesn't work because that area gets double counted. For example, two events that can happen at the same time. Say it's the probability of raining and the probability we'll play football. Okay, you'll play football in the rain, right? So if it's the probability of raining plus the probability of playing football, the area where it's playing football and raining got double counted twice, or got double counted once actually. It got counted twice. So this original rule doesn't work because we're double counting a section. So we have to modify the rule a little bit into what we would call the general addition rule, and I think this is the picture that I just drew. Oh, there we go. And so the general rule is this. For any two events, P of A or B, it's going to be P of A plus P of B minus P of A and B. Notice there's my picture. Because this area in between, this overlapping area between the two circles, got counted twice. And because it got counted twice, we subtract it once. Again, in the Venn diagram, this is P of A and B. This section that's overlapping is A and B. It's the area where the two overlap. So, because we counted it twice when we added P of A and P of B, we are subtracting it once from our probability. And again, this only happens when the events are not disjoint. So as you're setting yourself up for any kind of probability problem, you sort of have to ask yourself a question. Are these events disjoint? Can both of these events happen at the same time? If yes, then general addition rule. You're going to need to subtract out a section. If no, then you just add the two probabilities. Shall we do some examples? I think the examples are next. Okay, so a survey of college students found that 56% live in a campus resident hall. 62% participate in the campus meal program, and 42% do both. So just from reading the question here, can I both live in a campus residence hall and participate in a campus meal program? Yes, right? In fact, it kind of tells me that 42% do both. So I know from the problem stem here that these are not disjoint events. So what's the probability that a randomly selected student either lives or eats on campus is the question. I think I want to draw a Venn diagram first. No, I don't. That's weird. That's set up weird. So let's answer this question. What is the probability that a randomly selected student either lives or eats on campus? Not both. Right. Lives, so this is A or B. So one thing that I want to stress to you guys in this chapter is using your notation. Okay? Understanding how the notation works can actually really assist you in solving problems. A lot of times, because in probability we do have formulas, there are some formulas that we can use to solve things. And if you're really good at understanding the notation, then you can apply things to the formula really well. The other reason is, in probability has its own kind of logic to follow. And if you understand the notation, it's easier to know what you need to do in order to solve something. So let's stress the notation on this problem. First of all, how do we want to define event A? What's event A? What are we going to call event A? Based on the things that we have in our problem set here, what should we define as event A? Kelsey? Living on campus. And what should we assign to be event B? Blank. Participates in meal program. Okay. So these are two different events, right? Living on campus and participating in the meal program. So then my next question is, I want to know what's the notation for the thing we're looking for. Okay, P of something. What is the probability that a randomly selected student either lives or eats on campus? Can you have like a 15-second, 20-second discussion with the people around you? What's the notation for what we're looking for? Okay, have a conversation. Okay, some person. What's the notation that we're looking for? Hannah? Tell me, is it P of what? Say that again. Like an arc or like a U? They're both parabolas. Like a positive parabola or like a negative parabola? Yeah, N or U. Positive, yeah. Okay. So that's P of A or B, because it's asking us, does a student live or eat on campus? So this is just a straight up application of the general addition. And. Yeah. Or and. I always think of it as like the one that's upside down looks like an A, and A is for and. The other one is. The other one's not. So it must be or. So yeah, the way that this one's gonna work out, these are not disjoint events. This is a straight up application of the general addition rule. So that's gonna be P of A plus P of B minus P of A and B. So do we have all that information up here? P of A is 0.56. P of B is 0.62. P of A and B, that's the probability that they do both. That's 0.42. Given in the problem, yeah. And so then I just need to do some addition subtraction. Let's see, 0.56 plus 0.62 is 0.118, right? Which we know, by the way, is not a valid probability anyway, because they add up to be over 100%. So 118 minus 142, that's 161, 0.72? Am I right? 0.76. Oh yeah, because 8 minus 2 is 6. Yeah.
Don't you know?
Listen, math is hard. All right.
Do not realize what you be doing.
Don't care.
I wrote some.
Do what you feel is right. Will not matter on the AP test. The main thing you want to make sure of is always give yourself a couple of decimal points. Like even if you get an answer that's like 0.56248131, right? You don't need to write all of that. But what I would do is if you're going to change it to a percent, make it like 56.24%. Give yourself a couple of decimal points. Don't round off to the nearest percentage. Give yourself a couple of decimal points in the end. That's the main thing. Okay, questions, comments, concerns? Okay, here's the next thing. Take 30 seconds, and what I want you to do is off on the side where we did that problem, can you draw a Venn diagram of this? And draw a Venn diagram of what P of A or B looks like. Like shade in the area of the Venn diagram of what P of A or B looks like. And I'll give you like 30 seconds. That's a quick sketch. Right, what does A or B look like? I have a dream. Whenever I feel like that. So there's a way of feeling that in the orange that starts on the side and you peel out in like a spiral circle. Then when you get to the top, you change direction. If you do it just right and you take it all off in one piece, it makes a perfect like swirly mustache. One piece. I've done it once. So like I was at this math conference with Miss Barada, and I peeled the perfect one. It was like the perfect orange peel mustache, and I was so excited about it that I literally kept it. Like I was gonna take a selfie with me wearing my orange peel mustache, but I was in a room with a bunch of teachers, and I was like, I don't want them to think that I'm a moron. So I saved it because I was gonna do it later. No, because Miss Verada was like, oh, let me get that trash for you, and she picked up the orange peel and walked away too fast, and I was like, okay, no, fine.
Like the song from the Jackson started playing.
It's been like 7 years.
You know that song.
But I know it from the SNL sketch.
That equally is valid.
Yeah. Anyway, me and Aiden are having our conversation about references that you guys probably don't know. So.
What a bunch of nerds.
Actually, maybe you do, but.
What did I say?
Okay, so can someone describe for me their picture of what the Venn diagram looks like? Let's go. Someone who I haven't really talked too much today, and everybody who raised their hand I've talked about. Aiden, go ahead.
Circles.
Circles. That's definitely a part of it. Okay.
I think circles overlapping, and I have colored in here at all parts that were overlapping. So like the knot center.
Like this?
Yeah.
This is an or statement, so I do actually have to get that either. All of it. You color in everything on the middle.
I thought you couldn't do both.
This is the point is these ones are disjoint. Like these two events are disjoint. Now, did I just steer you guys wrong? No, I didn't. I'm right. It is the stuff in the middle as well. Remember, we double counted the middle. We only subtracted it away once because we double counted it. We're still counting everything in the middle. And here's the logic behind it. If I were to make the statement that I am going to play football in the rain, or I'm going to travel to space today, and then I went and played football in the rain, that's a true statement. I don't have to do both to make that a true statement. Does that make sense? Because I said or. That's why when we are talking about an or statement, we're talking about that area in between. Because even if you're one or the other, you don't have to be both. But if you are both, it's still a true statement that you're part of this P of A or B. So yes, this is shading the whole thing in. You won't find a problem on the AP test about it, but I really find it helps understand the situation better when we can understand what it is we're looking at on the Venn diagram. Okay, shall we do another problem? I don't know why I did that. Okay, so same stuff. What is the probability a student lives off campus and doesn't have a meal program? Can you guys make the notation for that? What is the probability a student lives off campus and doesn't have a meal program? Notice that it says and this time. And I would say once you think you have the notation down for that, can you draw a Venn diagram of that? Shade it in for the people in the Venn diagram that we're talking about. So you can make your Venn diagram like so, but then just shade in the section of the people we're looking at. All right, somebody I haven't heard from. What's my notation for this one look like? We're assuming that A and B is still the same stuff. The and symbol. That. Okay. Do we agree? It's okay to not agree. Yeah. In fact, I don't agree. Because A is living on campus, B is participating in the meal program. This is living off campus and doesn't have a meal program. Richard? Absolutely, you would. What do we call that from the last chapter? A complement. So instead of writing P of A and B, I'm going to write P of A complement and B complement. Right. P of 1, so say that again. Same idea, yes. Without knowing that the C was the complement thing. That's the same idea. It just wouldn't be the proper way of writing. Yeah. So you had the right idea. Okay. What about the Venn diagram? What people are we talking about here in the Venn diagram? Yeah, there we go. That's all these people. Right? Because all of the people in the circles either have a meal program or they participate or they live on in campus. The not having a meal program and the not living on campus, that's everybody else. So then the question is how do we find this probability? We can't use the general addition rule, at least not the way that it's currently stated, because this is an OR statement. So how could we find the probability of this? We need to find the probability of all of these things on the outside. Not multiplication rule, no, we're still using addition rule for this. Justin? So you're saying, do we do 1 minus 0.56 plus 0.62 minus 0.42? Right, that's the area of the circles. That's the thing that we found last time, right? If we take 1 minus that, we'll get everything on the outside because everything inside the rectangle is 1. This little section that we found right there was what we found was the inside of the circle. So we take 1 minus that, or what? Because that's the both. Remember, if we add 0.56, that's the whole circle. When we add 0.62, that's the whole circle. This area that's both got added twice, so we subtract it once. And remember, we found that was 0.76. So this is 0.24. Richard? Is there another way to write that? Yep. Mm-hmm. So if we use the addition rule with the two complements, we can have P of A complement plus P of B complement minus P of A complement and B complement. If we rewrote the addition rule, this is the addition rule, it's just the complements instead, and that's okay. The other thing that we could do is we could figure this as an equation, add P of A complement and B complement to both sides. Notice that I'm going to actually just solve for this thing right here. The P of A complement and B, B complement plus P of A complement or B complement equals P of A complement plus P of B complement.
Very roundabout way.
And then I can subtract this one. What did you do? Basically, yes. I mean, it's the same equation as before. Yeah, they get so angry. But I mean, if you think of this as like A, B, C, D, all I did was add D to both sides and then subtracted A from both sides, right? I mean, it looks more complicated because it's a bunch of symbols, but it's nothing huge. But the point is that the formula that we created can be manipulated algebraically, and we can solve for any kind of thing. And it doesn't matter that we're using A complement and B complement. It's the same formula. In fact, I could do A or B complement, and then this whole formula becomes the same thing. It's just, instead of being A complement, it's just a plain A. Like that. But it's the same thing. Well, I mean, it's using the notation, right? And remember, I'm stressing using the notation because it really does help to understand a lot of these problems when you understand the notation. Questions, comments, concerns here? That's just the side. Not a comment so much. Okay, let's do some more. Whoa. Whoa. Okay. There's a second problem on this slide, and that messed me up. Let's just erase all that. What is the probability a student lives in a residence hall but doesn't have a meal problem? A meal program. Okay. Yeah, you might have a meal program. That's probably. Especially, yeah. Can you make the notation, draw a quick Venn diagram, find the probability? I'll give you like a minute and a half. You guys will do it all on your own. Make the notation, draw a Venn diagram, try to find the probability. Organism is probiotic. Yeah, but when you say probiotic, it sounds like it's not, but literally. So it's an interesting question. Is this an and statement or an or statement? It's definitely an and statement. What? Oh yeah, I gotta get you. And I have your notebook.
Oh, yeah. On the last one, yeah. One of them I looked at that. So the last one is like
We graded
an
it.
odd number.
We graded it. I didn't put it. So like 30 seconds here. You might be right, but it's just wrong. There are simple ways of doing it.
Yeah, but
You're only shading in the part that are part of the line. Okay, so let's do the notations. And the reality of this one is actually that the formula doesn't work so fantastic for this one. It really is much easier. Knowing the notation is good for what you're trying to find, and knowing the Venn diagram is good. But the formula itself is actually probably the more complex way to do it, in my opinion. You can do it, but it's just more complex. So first of all, what's the notation we're looking for? Someone I haven't really heard from today. I've heard from you. I've heard from Richard too. Heard from Brian too. Somebody in the front right here, the back left, the four gentlemen in the back left. Haven't heard from any of you guys today. Kelsey, go ahead. So probability of A and B complement, right? Because it lives in a residence hall but doesn't have a meal program. Okay? So A and B complement. And if I were to draw a picture of that, okay, so here's the part that's interesting, right? This is an and statement. So we're only looking at the areas where A and B complement intersect. So this circle right here is B complement, which means everything on the outside, including this stuff in the A circle, is B. Excuse me, this is B. So these are all B complement. Okay. But you need the areas that intersect A and B complement, which means the only area you are shading in is this circle right here. Notice that it is not the area where it is both. It is just the area of A that is part of B complement. Fine. Yeah, here I'll shade it. I'll highlight that in yellow. All of this is B complement. A complement would be all of that stuff out there, but not inside the A circle. Because remember, this circle is B, and everything outside of that circle is B complement. So it is the whole space.
So the outside represents complement outside of the circle.
Outside of both circles is A complement and B complement.
Okay, so for A, represents both.
Yes.
Okay.
Yes.
So the
0.56 is the area of all of A, yes. Okay, so then the next question is, what's the probability? How do we find the probability? We're just looking for this section right there. As Nicole just said, this whole section right here is 0.56, and that's perfect. And the reason why we do that is we're looking for just this area in here, right? I know that A, the whole circle, is 0.56, and I know that this little section right here that's both is 0.42, and since this, if I'm looking for just this area that's not in there, 0.56 minus 0.42, which is 0.14? 0.14. What's that? You don't have to use the formula is what I'm saying. Yes, using the formula on this one would be more complicated. Because if we wanted to use the formula, we'd be using this thing down here that I wrote, which is P of A plus P of B complement minus P of A or B complement. And that's a much more irritating thing to do. This right here, that was my barbarian cry. That right there is the same as that right there. Did you say fix my ankle sign? Cool.
There you go.
Yeah. Yes. Would we only use that if we didn't have 0.42? Yeah, but then you'd have to find these other things. Like P of A we have, 0.56. P of B complement we don't have, but we can find. What's P of B complement? 0.38. Yep, 1 minus 0.62. This is the one that's going to be hard to find. P of A or B complement. Because that's this whole space and this whole outside space. So you have to figure out what that is. Which is one, let's see. Well, the previous problem, this one was P of A complement or B complement. So we could take this answer for that one. But yeah, that one would be, that's what I'm saying. The formula is good, but it's not perfect. What time do we get out of here? Do we get out of here at 50 today? Okay. So again, part of what I'm trying to get across to you guys here is that we need to be flexible, right? Flexibility when solving these problems is really important because we can use formulas, but there are times when the formulas won't do as well. And so it's much more important to think about the problem logically. And it helps us to build that by knowing the notations, building the notations, and being able to provide the Venn diagram. Yep. 0.14 is the final answer on this one. And like I said, we didn't need the formula at all for that one. We just we found out the area of the picture that we needed to find, and we just used the information we had to do that. What else? All great questions. I'm changing your homework to 1 through 4 because we didn't get to the next set of problems that I wanted to get to. Excuse me. So, if you could read through, what page do I want you to read? because I want you to read this. I want you to read about the stuff that we're going to learn tomorrow. So I want you to read through at least page 349. Yeah, 349. So read through 349. You can start your chapter 15 notes. Friday, probably. So, read through 349, because I want you guys reading about the next thing that we're going to learn about tomorrow. And then do those 4 problems. Remember, I'm gone tomorrow. I'll have a video for you, plus some problems, and I will provide you guys with the homework answers as well. Okay? So you guys can go over those together. And I think that's it.